So we have our simple stream directory here, our simple API. So if I take this and so I just need to install npm install Express. So Express is a web framework that sits on top of Node.js. Super easy to use, but yeah, so that should be awesome. So it was installed. And alright, so let's start with the new file. So we're just going to create index. Wait, is this in simple API? Yes. So just create a new file, index.js. Alright, so const express is equal to require express. Alright, so that's how we pull in the Express web framework, and then const app is equal to express. So this is like a constructor. So if we look at this function definition here, so if we click on it, you know, there's some, like a whole bunch of extra stuff that you can use here. So anyway, and then, so you can say, I think you have to tell it exactly like how to parse JSON. So I think you could say like app.use express.json. All right, and then so let's say we have a simple API that just wants to, we want to define a ping route, right? So if we say app.get ping, and then so in order to define a route of an API, you say the path, and then followed by a function that takes in a request and a response object. Alright, so in the request you have access to a few things. So you have the request.body, which you can use in a post request, and then you have the request.params, which is like, actually, yeah, and then you have request.query. Okay. So like if you wanted to use request.params, which I'll get to in a second, so like if I had an ID or something, I could say like request.params.id, and that would pull out whatever value is at the end of the route. Whereas request.query would be like if you were to throw an exclamation or a question mark and then and you say like name is equal to Gerard or something, and blah blah blah, you could do rec.query.name, and so on. Alright, but let's just define this quick small route here. So we're just going to say, I think you can say something like rec or res.send pong. This is just like a nice health check endpoint that we can use to get the ping here. And then you need to tell it like what port to listen on. So you say app.listen and then the port. So the port in this case, I'm going to say like 8000, and then you can pass in a function. You say console.log app is listening on port Actually, I want to make these backticks. 4. Alright, and okay, so to start your server, you say ls node index.js. Port not defined, yes, const port is equal to 3000 or 8000 here. So I can just say port here. Nice. And oops. So let's start it up. So node index.js. Awesome. All right. So now I'm going to open up Postman. So here's a Postman, and so Postman, right? So we have a GET request, and our localhost is going to be 8000/ping, and we send a request, and we get Pong back, right? Right. So that's super easy. So let's say, for example, we have a GET request that accepts a query. So let's define another route that accepts a query. So we're going to say app.get, and then the route is hello, and then the query is name is equal to Gerard, right? Or so let's say you have a param and say name, right? And then you can say rec.res, or rec.res, and then response.send hello, and then rec.params.name, like that, right? And then we need to restart our server. Awesome. So now I have go to the hello route /Gerard. Awesome. So I say send, and there we go. And then I can just put caps like that. It says hello Gerard. All right. So that's super straightforward. Okay, so let's say we have a post route, right? So let's say a user wants to, and the reason why you might want to have a post route is, say you want to create a user or something, right? So let's create an array. So let's say just like a dummy array to hold the user. So let users is equal to an empty array, and then let's create a simple class called user, and then it's going to have a constructor, and then ID and name, and then we're going to say this dot ID is equal to ID, and this dot name is equal to name. Super straightforward. And then we're going to say we're going to define a function. So get ID, function get ID is equal to is this, and then we're just going to, why is this indenting now correctly? Or get ID is equal to return this dot ID, and then get name is equal to this dot name, return this dot name, and then so say we want to change the user's name, so we're going to say set name, and then name, and then we're going to update that new name. So this dot name is the name. Okay, so every time we want to create a user, we'll use this class as a template to create a new user. All right, and then we just want to have a let next ID is equal to 1. All right, so now when we want to create something in our database, so this is how we're going to simulate a database, is this this user's array. So what we're going to do is we're going to say app.post. So we're going to say, let's say we want to create a user, and we're going to say app.post of user, and then rec.res, and so we need to, so the parameters we're expecting is just a name in the body. So in this, we're going to say const, we're going to use some destructuring, we're going to say name is equal to rec.body. So what this will try to do is pull out the name field in the body object that we pass in the request, and then we're going to say users dot push new user of ID ++ and then name, and then res.send user created. Alright, awesome. So that's one, and then let's say app.post or .put. So this is when we want to update user info. So like update user info, i.e. name. So we're going to say app.put, and then the path would be user, and then you're going to say request to response. And as you can see, defining an API is like super straightforward when you know exactly what you're going to do. So typically you have an object that represents a service. So in this case, it might be a user service. So typically you might want to create, read, update, and delete a user. So perform CRUD, and that becomes your API endpoints. So we have a post, put, get, and delete, right? So anyway, so let's say we want to update a user's name. So we can say, so we have to search for that user. So we can use a for loop. So we can say for var I is equal to 0, I is less than users.length, I ++. So so if actually we want to pass in an ID. So we want to be able to say, given an ID, update this user. All right. Or conversely, if we pass it in the request body. So if we pull it out here, so we say const ID and name is equal to rec.body. So this means in this endpoint, API endpoint, we're going to expect the caller to pass in an ID of the user we want to update and the new name of that user. So we can say if users.get users of I.get ID is equal to ID, then we can just say users of I.set name is name, and then we can say res.send user updated, and then we can say break, or I think return or something like that. I don't know. I think you do return. Otherwise, you can say res.send no user exists with ID, and then you say the ID. So let's use backticks ID like that. All right. So we have a simple mimic database here with this users. So let's try to create a user. So we're going to use post, and we're going to expect a name, and then we're going to instantiate a new user object and push it to users, and then send users created, and then we have a put route that we're going to use to update the name. And then let's just actually define one more route, app.get user and then ID, and that's going to take a rec res. So let's just copy this. All right, and then we can do an inline rec.params.id like that. All right, so now let's restart our server like that. All right, awesome. All right, so I think the route is user, right? Okay, so we're gonna say localhost 88,000/user. This is a post route. And then we have the body, and then we're going to say raw, and it's going to be JSON. All right. So now we say we expect a name object, and we're going to say Gerard. Okay. So let's send this post request. So let's remember what we're expecting to see. Let's minimize that. So we're expecting to see that we're going to expect a response that says user created, and let's see what happens. ID is not defined. Post. Wait, what? post. ID is not defined. Wait, hold on. I clicked post, right? Yeah. Let's see. Oh, weird. So, I don't know, actually. Let's just make sure this is getting called. Console log rec.body. And restart our server. Awesome. And we send this request. And let's open up this. Yeah, so it is sending the post request. Oh, wait. It's next ID, right? So it's next ID. Awesome. Alright, so let's restart our server, and now this should work. So we send the post request, and we have a user created. Alright, awesome. So now, let's try to get that user. So we know for a fact that the user ID is going to be 1, so let's just change this to a get request. I'm going to say user ID 1, and it's hanging. So why is that? So, this is not right. So we want to say, we just want to say return res.send user of I. Users of I. Get ID is rec.param send ID, and return. I think this is valid. I don't. It might not be. Actually, I think this is alright. Let's try it. Alright. So unfortunately, we need to recreate the user because we're not using a persistent storage method. So every time the server comes down, we need to restart it. So we say localhost 8000. And then /user, and then we need a body, raw text JSON, and we're just going to say name is Gerard, right? And then we send it, and user is created, awesome. And now we need to get that user, so the ID should be 1, I think, right? Based on this. So let's look at the code, right? So we use next ID, and we say ++, so it increments it after. Okay. So user /ID. Alright, so let's try it. So the ID should be 1, and we send it. Yeah, why is it hanging? Let's see. Let's make sure it is. Users are a good ID, right? Let's just do something else too. Users of I get ID. And let's restart. Alright, so we're just going to send a post request like this. Users created, and we don't need a request body. None. We send. And let's see. Okay, so it is getting 1. And then let's console log. Let's just print the users as well. So make our lives easy. Alright, so we gotta create. Awesome. And so user was created. ID 1. And the name is Gerard, right? What? And it's not treating it as a string, is it? This is 1. So I'm also an idiot because this is what I was copying and pasting. So we just want to res.send. Alright. So let's restart. And here. Alright, user created, and we get that user still. What the heck? So this should be true. At least once, right? Return. Alright, user created, and again, okay, so it's false. Wait, what? What? The ID is 1, right? I'm not going crazy. Or is it treating it as a string? I think you could do like type of. Alright. And it is a string. Okay. So you gotta convert this to an integer. So we have to say parseInt, parse long or parseInt. Weird. Okay, so then parseInt. Alright, so now, and I also need to fix this. So parseInt out of this. Nice, okay. And let's restart. And, whoops, cancel. Awesome, user's created, and we're going to get that user, and there we go. Nice, so we have that user back. Alright, so the bug there was that I was sending a string as JSON, and then wasn't actually converting it back to an integer, which is expected on the server, unfortunately. So that's that. And I'm just going to get rid of these console log statements because we don't need them. Alright, so now let's test this put route. So the thing with the put is we're going to send a request body, and then we're going to send the ID that we want to update, and then we're going to update the name. Okay, so now we're going to create this route. We're going to, and this is going to be a put, and this localhost 8000 and user slash, no, just user, right? And then you say body is raw JSON, and then the ID that I want to update is 1, and then the name that I want to update it to is G, just like a nickname, right? Alright, so I'm going to send that request, see what happens, user updated. Now if we try to get that user, let me say send, and a new name is G. Okay, so that's super awesome, right? Because we can now create a user, we can update a user, and we can get a user. Now, the thing that we want to do next is speed this up. So this is super slow, right? Because at the end of the day, we're looping over every potential entity in this array of users, and then we're searching for one to see if it exists, right? So instead, what we're going to do is we're going to, instead of having a list of users, we're going to have a map of users. So it's just going to be an object. Actually, do I want to do that? Let's just do a map. So the map and the keys in this case is going to be the ID to the user object itself. So this will give us constant lookup time. So if we change this, instead of users.push, we're going to say user dot, let's see, what is the API for users? I think it's users dot insert. Alright, I'm going to look up the map API JavaScript. No, not the map function, the map object. So there's get, set, set. Okay, so the object is users.set, and then it takes in the key first. So in this case, it's going to be, so let's create the user first. So const user, const new user is equal to new user of next ID plus plus and name. Okay, so then we're going to set, we're going to say new user dot get ID and then new user. This will allow us to look up that user super fast. Okay, and then we're going to put the user. So instead of this, so instead of this big old for loop, so we're going to say, we can just use a conditional statement. So we can say if users dot has ID, then we want to set, so say users dot, actually let's, so this is, I'm not familiar with the maps API that well, so we're just going to say const user is equal to users dot get ID, and then we're saying user dot set name is name, and then I think you have to put it back. So you say users dot put ID user, like that. All right, and then you say user updated. Awesome. Otherwise, user doesn't exist. All right, and then same thing here. So we're just going to get that user. So it's just going to be if users.has rec parse int. I'm going to have the same issue as above, by the way. Has parse int of rec.params.id. Actually, I'm going to take this line. Let ID as int is equal to p, like that, and then ID as int, and then we're going to say res.send users.get users.get ID as int, like that, and then otherwise else res.send no user exists with ID as int. Awesome. All right, and then the same thing up here. So let me just get this, and p, and then it's just ID because we're pulling it from the body. ID as int, and then ID as int, and I think, yeah, it's ID as int, like that. Awesome. All right, so let's restart our server. So, new map. Yeah, so you have to instantiate it. Okay, awesome. All right, awesome. So server started up. So the optimization that we just made is that we're using a hash map for fast lookup instead of an array that we have to loop over each time. This code, I'm questioning if I actually need to like get the user, set the name, and then put it back. I think I can just do it in a one-liner. I'm not quite sure though. Somebody will have to check me on that. But now, okay, so we're going to create the user. All right, and we're going to get the user. All right, so the name is Gerard. Whoops, I don't want to sign in. And then we're going to update it to G. Users.put. Put isn't a function, it's set. Yeah, all right, so let's restart. All right, so now we just post that same user, we get the user. All right, that worked, and then we update it to G, user updated, and then we get that new user. Awesome. So now, instead of this, we should expect a response. So there's no ID2 in the database, right? Or in our quote-unquote database. So we should get an exception. We should get no user exists with ID2, and then the same thing if we try to get it with 2. Awesome. Awesome, great. So this is basically all it takes to create a backend API. These functions will get more and more complicated as you go on. So as an example, all right, so let's say we want to design this software to be really straightforward to use and like easy to maintain. So what we're going to do is we're going to have a new folder. We're going to call it models. So this is where you would house all of your structs and classes that are just data objects. So in this case, it would be user. So I'm going to take this code. Actually, I'm going to actually create a new file first. I'm going to say new file, user.js, and then inside of here, we're just going to take this object, and we're going to paste it here. And I think export default user. Yeah, okay. So now I can import const user is equal to so this is, I'm not too sure about this, so import user from models/user, like that. And I think the import statement needs to go at the top, like that. Okay, so now I should still be able to instantiate users. And then, so now, let's say we want an API. So what I can do now is I can say new folder, API, and new file, api.js. So the benefit of doing this and not defining it in your index.js is your index.js should really be used to handle like server setup. So you don't want to necessarily define your whole API in this index.js. So instead, what I'm going to do is I'm going to take this here, and then I'm going to put this in the api.js. So instead of app, so I'm going to say const express is equal to require express, and then I think const router is equal to express.router, like that. I can't remember if it's capital or lowercase, but we'll figure that out in a second. Control R, Control F. So I'm going to find app. Everywhere there's an app, I'm going to replace it with router. Alright, and then I'm going to say export default router. Alright, and then in index.js, I'm going to say I think I can do this, import router from API, like this, and then I can say app.use router. So what this will do is it'll basically say, and I actually need to import user into here. Alright, so yeah, so what this code allows me to do is it's just pulling in a router from the API folder and saying use this router as well as any other API routes that are defined. So it'll register the routes that I've defined in this API file to be used in this server. Okay? In this app, actually, I should say. So now I pulled out my class, my Pojo, or plain old Java object, or just a data class. Then I have my API in a separate folder. And then that should be it. So nothing should break. I just made my code a little bit more. Cannot use import statement outside of a module. Maybe it's a require. Yeah. Or, and then you say require, and then the path, API. Interesting. And then I should be able to do this, but it's .. Yeah. Alright, let's see. Will this work? Index.js. There's no router defined, so I can maybe do that. Alright, so it's yelling at me because I cannot. Alright, so maybe it's const user equals require. I'm not a JavaScript expert, by the way, if you can't tell. But this is just a quick example. Unexpected token. Oh, do I need to do something like module.exports router? Oh, okay. Okay, so this makes a lot more sense. I can say module.export is equal to user, I think. And then I can use the require syntax. Right? And same thing here. So I'm just inlining this. So to make this a little bit more explicit, I can say const router is equal to this code here. So instead of this, and do that, and then I can say router. Like that. All right. So hopefully, wow. Maybe it's capital R. I think it's capital. Nice. All right. So now my API is working. So let's post. Send a post route. User created, and I'm going to get that user. 1. Nice. And then put. Instead of 2, I'm going to say 1. Awesome. And then I'm going to get that same user. Great. Okay, cool. So we created a very, very simple API. Okay, so let's say that we have a little bit of a small microservice architecture that we're working with here. Okay, yeah, so say we're working with a little bit of a microservice architecture, and hold on. I'd love to finish the chess tutorial, but it's just going to take some time. This is going to take some time. Alright, so, okay, so let's say we have a microservice, and let's say we have a user, and then when we create a user, we also want to, say, generate a, like a profile URL that they can use. Like we can create another API. So we can create another service. So let's do that. So we're going to say new folder, and inside of this folder, this is going to be second service. All right, just let's call it like hello service, like email service, right? And then this sends an email or something. It's not really going to send an email, but just to illustrate the utility here. Okay, so we're going to need, in this simple API, we're going to need npm install Axios. And then we're going to use Axios to send requests to the other service. And then we're going to go to email service. And then here, we're going to say npm init-y. And then we're going to say npm install express. And awesome. Okay, so once express is done, we're just going to create a simple, very simple web service here. So we're just going to say new file, index.js, and all it's going to do is it's going to just pull this in, we go require express, and then we're going to say const app is equal to express, like this, and then const app.use express.json, and then After that, what we're going to do is we're going to say, just real quick, app.listen. We can't listen because we're local. We can't listen on 8000, so we're going to say 8080. And then we're just going to say console.log, email service is listening on port 8080. I'm getting lazy right now, so I'm just going to have this like this. Alright, so now we're just going to, so what we want to do is we want to be able to send a quote-unquote email to a new user that's signed up. So we're just going to define a quick post route. So we're going to say app.post, and then it could just be a slash route, because this service is only going to be sending emails, so we don't really need to. So post is going to be the equivalent of sending an email. All right, and then we're going to say response, and then we're going to, so what we expect to get in the request body is going to be, say, a name, right? And then it's going to say rec.body, and that's it. And then let's just simulate. We're going to say const or res.send email sent to, and then we're going to pass in the name. Alright, so this is how we're going to submit. So basically, truthfully, there should be some function here that uses SendGrid or something that's going to send an email to someone. Alright, now, so this is all we need to do for the email service. It's super simple, right? Now, the trick is inside of the user service, is that when we create a user, we need to actually create we actually need to send that email once the user is created. Okay, so so we're actually going to say, so in the Axios docs, they say how to create a client. Let's see. Yeah, okay. So in here, so we're just going to say, like a quick callback after the user's created, we're going to say Axios, const Axios is equal to require Axios, like this. So we're going to say Axios.post, and then the path is going to be, or the method, no, it's Axios.post, and then it's going to be the http:// localhost 8080, and the body, how do you set the request body? Let's see. Yeah, okay. And then you just define an object here. So I'm going to say name is equal to, and so then we can just pass in name, because the API is super straightforward. So then Axios post, and then this is a callback. So then we can say .then res. So then we can say res.if res.status, or I think there's a status field, but let's just not in the meantime. So we're just going to say res.resp to avoid name collision, and then we're going to say res.send. So after we sent the email, we want to send a response, and we say user updated, and then email successfully sent to plus name, like that. Alright? And then we can say that catch error like this, and console log error. Alright, cool. So this will do is we're going to create a user, add them to this map, and then we're going to have it send an email when we send a post request with the name and the body. So inside of the index.js here, let's say console log, and we're going to also print this. All right. Oh, I want to post it here too. All right. Let me just open up another terminal and okay. All right. So I'm going to make this bigger so you can see, and then I'm going to say cd email service. Here. Cd email service. Nice. And then node index.js. Okay, so email service is a single port 8080, and then I'm going to use this other one. So I'm going to say node cd simple API, and then I'm going to say node index.js. Okay, so email service is listening on 8080, and then the simple API is listening on port 8000. All right, so now let's create that user and make sure that an email gets sent. So now, so I sent a request, and then it says email sent to Gerard. So that's literally all microservices are. So you have nicely encapsulated pieces of code that run on different processes on different ports. So typically, what this means is like they don't necessarily run on the same computer. So what you would typically do is you would encapsulate each service in its own Docker container, and then you would use Kubernetes to then orchestrate the service discovery as well as routing requests to each service. But a big problem that microservices have is called service discovery. So how do you know ahead of time which port a particular service is listening on? And how do you know what the host name? So in this case, it's super easy because I know it's on the same computer, so I can just say localhost. But presumably this is going to be on another host URL and another port that I don't know ahead of time. So that brings into question, like, we need to have some config, some way to have what's called service discovery. Kubernetes does a really good job of this by saying when you create a service, it gives you a cluster IP address. So then you can use that IP address to, and then so every I don't want to say pod, every service in your cluster then has environment variables that point to each service. So if I have so as an example, in Kubernetes, what you would have is you would say email service host is an environment variable, and then email service port will give you the host and port. So instead, what I could do is I could just put the host and port here like this and then send a request. And then Kubernetes will handle the routing and the load balancing over however many instances of the email service I have. Okay? So it's pretty straightforward when you use containerization and Docker with Kubernetes to deploy microservices. So yeah, I built a simple API, but at the end of the day, this is all any company does with the backend API is they define routes, and it allows them to serve requests and send responses, right? And then whatever the route is actually doing in the internals can get infinitely more complex because it's not just for example, we have an in-memory hash map that represents our database, but presumably what we're going to do is this line will be replaced with a call to a MySQL database or a cache or cache and a MySQL database, and then we send the email, and so on. And then when you want to put to the cache and then put to the database, or maybe you publish to a Kafka topic and stuff like that. So all of these things are all used as ways to scale this service and make your service more resilient. Because right now we lose user information by only having this hash map in memory of the actual service. So when the service goes down, all the users and their information are gone. So we want to store that in a persistent storage called a DB. So you could use Mongo, you could use Firebase, you could use MySQL. It doesn't really matter how you store. But then let's say your application gets super popular, and then all of a sudden you get 1 million signups in the span of 2 hours, right? It's something ridiculous. That's when you really expose not vulnerabilities, but flaws in your software design, right? So if, for example, you have blocking code that blocks on this, thread here, then if you get slammed with 1,000,000 requests, it's going to probably crash your server because you're going to be holding on to way too many requests and you're not going to be able to serve them, and it's going to cause your latency to spike, and there's a whole bunch of issues with that, right? So what you typically could do is you could use some concurrency, you could just publish to Kafka and do some async processing as well if it doesn't need to be a synchronous request response. So yeah, there's some pretty cool stuff that you can do to scale your backend microservice, but I just wanted to give you guys a quick overview of what it's like to create a backend API. It's super easy in JavaScript, but I do want to note that a lot of big tech companies use Java web frameworks, so some of them might use like Java Spring or some custom internal framework. I know at Twitter we use Finagle and Finatra, which are RPC-based frameworks. By RPC, we mean remote process call. So that's exactly kind of what this is. It's like you're calling a service, or you're calling a function on a service that is in a different process or in a different host. You may heard of like the concept of gRPC. It's a very similar concept, but gRPC is a binary protocol. So what we've been doing is we've been building a JSON API, but Apache Thrift and Google's gRPC are binary protocols. So what that means, it gives you like this inherent level of type safety. So ahead of time the types of the data that you're dealing with, and you're not going to have an issue like parsing strings into ints. You're going to know with some confidence that this ID value is going to be an int when you deserialize that gRPC object or that Thrift object. That's where you would probably, most companies should use Thrift APIs, just because you can kind of guarantee that you know what the types of the data you're dealing with, right? So yeah. Any questions? Let's see, I've been talking a lot. Oh, nobody's really watching. Cool. That's all I really wanted to talk about today, but thanks for watching. All right.